In this chapter, we'll talk about setting up a Dante Domain Manager server. But before installing DDM, it's important to know what we need for system deployment. Dante Domain Manager is a software appliance delivered as an ISO file that we must install in a server environment. In this chapter, we are discussing the installation process. Once the installation has been completed, you can use the built-in web server to access and configure DDM using any web browser. We currently recommend DDM get installed in a company's virtualized environment, similar to other enterprise-grade software. This allows you the most functionality and performance by leveraging existing IT resources. We do not recommend installing it on any typical OS-based Type 2 hypervisor, for example like VirtualBox, because OS updates can have a negative effect on keeping the server up and running properly. Another essential piece is having the network infrastructure in place that we talked about during the 3 levels of the Dante certification program. You must use Dante devices with at least version 4.0 firmware in order to achieve the full benefits of the Dante Domain Manager. But don't worry, we will talk about this in detail later. Finally, Dante controller must be at minimum of version 4.0 or higher. The Dante Domain Manager software, technical documentation, including guides for installing DDM on popular hypervisors, FAQ, knowledge-based articles for troubleshooting issues, and the MABs for SNMP integration can be downloaded from the Audinate support page at audinate.com/support/Dante Domain Manager or by scanning the following QR code. Now, you have 2 ways of installing DDM: on a dedicated server or in a Type 1 hypervisor environment. We always recommend to use a virtual machine such as VMware, Hyper-V, or another Type 1 hypervisor for DDM. Type 2 hypervisors such as Oracle VirtualBox can be used for initial testing and demonstrations, but are not suitable for permanent installations. The first step of a VM installation would be to directly import the ISO file to the virtualization platform. If you have not done this before, don't worry. We have a short video on how to do it, and you will see that it's extremely simple. Traditionally, most server applications run on bare metal servers. Today, the pros of a hypervisor-based deployment outweigh the cons in most scenarios, and an alternative to server installation is the use of a hypervisor. A hypervisor is a software that enables you to run virtual machines. This can either be native or Type 1, where the hypervisor is installed directly on the hardware, or hosted, also known as Type 2, when the hypervisor is installed on an OS platform. An example of a Type 1 hypervisor is VMware ESXi or Microsoft Hyper-V. Popular Type 2 hypervisors are Oracle VirtualBox or Parallels Desktop. Now, if we wanted to, we could put something else in that virtual machine, right? Like Dante Domain Manager. We discourage you from running Dante Domain Manager on a machine you are using as a desktop or laptop. Dante Domain Manager needs to be a permanent network asset. You don't want to be in the situation where the server disappears every time your desktop hangs up or performs a routine system update, right? A better way to manage this is to eliminate the complexity and weight of the underlying operating system. As we mentioned in the introduction chapter, the licensing model for DDM comes in 3 editions: Silver, Gold, and Platinum. If you remember, each edition supports a different number of devices and domains. So that means the hypervisor or physical host machine must be configured to provide sufficient system resources for the virtual appliance based on the product edition. DDM requires a minimum of 2 CPU cores. The RAM will need to be increased from 4 to 8 GB depending on whether you are using Platinum or the other editions. Larger networks beyond 200 devices will have increased CPU and RAM requirements, which are 3 CPUs and 16 GB of RAM. If in doubt about specific use cases, feel free to reach out to our solution sales team, who will be more than happy to help. Typically, 20 gigabytes of disk space would suffice for a DDM deployment, but we recommend additional space in large networks in anticipation of a high volume of alerts and changes. Well, with all that being said, now let's demonstrate how to install DDM in a hypervisor. The process we're going to show you next is the most common and easiest way to do it. You'll also notice how fast it is. Okay, first thing you need to do is to download the DDM software, and that is done from our website. So, if you go to audinate.com, you will be able to see the support section in the main menu. From there, navigate to the Software and AView Support section, where you'll find a link to Dante Domain Manager. Once there, you should see a link to download the latest version of Dante Domain Manager. Once you log in using your Audinate user account, you'll be able to download the latest ISO image. Our current demonstration video is based on VMware ESXi, which is popular among a lot of DDM users. But obviously, you are free to use whatever works best for you. And we already talked about the options earlier in this chapter. The first step is to import the DDM ISO image to the platform for the server installation. After that, we will be ready to create a virtual machine for DDM. So, in order to run DDM, which is an appliance that runs on CentOS Linux version 7 and comes pre-installed with the DDM application, we just need to create a new virtual machine and give it a name, which in our case will be DDM Standalone HA node. After that, we select the Linux family, and it's going to be based on CentOS 7. Go next, and in our case, we're going to install it on the hard drive. We go next again, where you have to choose the data store and configure other parameters. The recommendations for running DDM are defined in our user guide. So please refer to the user guide in order to fine-tune or adjust the system requirements up to your installation depending on the number of devices and the DDM version that you intend to run. In this current demo, we're going to use 2 CPUs, which is always a good start, 8 GB of RAM, and 20 GB of hard drive. That configuration will suffice for most of the common DDM installations where you use silver or gold licenses. After that, we choose the right network interface, which has been configured to have visibility of the Dante network. Finally, we boot the virtual machine with the DDM ISO file. Click Next, then Finished, and we are ready to go. Now, select the DDM you have just created from the virtual machine's catalog and then click on the Power On button. In the console window, you'll be able to see the server boot up to the startup screen, giving you the options to either install DDM or test the media and install DDM. We go straight for the Dante Domain Manager installation. The installation process from here on is automated and will not require any user input. Let's fast forward this until we see the installation completed screen. After that, we just press Return to quit and the virtual machine is going to reboot automatically. The DDM application, once booted up, will present us a blue screen with the DDM administration menu. Now that we have Dante Domain Manager installed, you have access to the appliance menu. This gives us basic access for system configuration and troubleshooting. The first thing you see at the top of the menu is the IP address that the server has resolved to. By default, this will be set by DHCP. But if you want to set Dante Domain Manager to a static IP address, you can use the menu item 3 to do that. This feature allows you to add, edit, and delete a static IP address for your DDM server. The appliance menu gives you a few other options that could prove they are very useful during your initial setup. The default host name is DDM, but you can change it from the menu. Also, you can do a network diagnostics test, which can ensure you have your network setup correct. And finally, you can also configure NTP servers, which become critical when setting up high availability. Let's configure the network interface. For this setup, we're going to set up an IP address 10.101.1.100, subnet mask of 255.255.255.0, DNS server 10.101.1.1, The gateway is going to be the same as the DNS server. And the search path will be lav.emea.dante.onl. In order to apply the network configuration, we need to reboot the server. So in the appliance menu, there's an option called Shutdown Reboot to do just that. Don't forget to press the spacebar to select the Restart option. You'll see an asterisk appearing in the brackets, which means you are restarting and not shutting down. Same thing. Let's speed this up so that we can get to the appliance menu again. Now, as you can see, the server has the IP address that we've just configured. This now means that we can access the DDM web interface in one or two methods. We can use the IP address configure, or we could use the fully qualified domain name allocated for the DDM in the DNS server, which in this case is ddm.lav.emea.dante.onl. If you are setting up DDM in an enterprise network, it's important to coordinate the setup activities with the responsible departments. When you first connect to the DDM using the browser interface, you'll be presented with the End User License Agreement or EULA. Click I accept. Next, choose the type of installation. The options available are Fresh Installation, Restore Configuration, which is how you'd restore DDM from a previously backed up version of the server. The other two options pertain to high availability, in which we can set up a DDM either as a node or the arbiter. We'll go into the details of this in another section. For this particular install, we will select Fresh Installation. The next screen lets you select the role for the DDM installation. You could be a third party or the end user. Once you've selected the appropriate role, you will need to set the admin password in the next screen. At this screen, you can also generate a recovery code. We recommend you to save it in a safe place in the event you need to recover your account. Click Next, and this will take you to the product key screen. Activating the product key will require internet access. We only need internet access for Dante Domain Manager to activate, deactivate, or update the machine. Once you've done that, you can take the machine offline and put it in a network with no internet connectivity. The next install page is the Upload TLS Certificate section. For best security practices, we'll want to secure the connectivity between the web browser and the DDM server with a TLS certificate. So if you have this information, DDM lets you to import your own TLS certificates into the server. We can either copy and paste the text or simply upload the generated certificate files to the server. We're going to do that first for the private key and then for the certificate. If for any reason you don't have this information ready, you can always skip this and add it at a later time under the settings in the network and security section. If the certificate has been applied, you'll need to refresh the page so that it takes effect. In the step 5 of the installation, we must enter the FQDN or full qualified domain name that has been created in the DNS server. In our case, the server has detected it automatically. This is also something that can be set later once you've coordinated with the other departments. Finally, we have to create the first domain for Dante Domain Manager to use. The server needs at least one domain. So we are going to name ours as first domain. Remember that we can change that name later, and voila! Our Dante Domain Manager server is all set up and ready to go. Just to restate, the Dante Domain Manager server doesn't always need to be connected to the internet. Once licensed, it can be disconnected from the internet access. However, internet access is required to check for and perform software updates, to access NTP servers when using high availability mode, to refresh the license when adding expansion packs or other optional features, also to reach user guides, or if you need to deactivate the license to relocate to another virtual machine, for example. So all this information is good to know when planning your network deployment with DDM. So these are the sites DDM needs to connect to on port 443 to get the information. Finally, be aware that DDM version 1.2 or higher already support web proxies. Like we've mentioned before, DDM acts as a proxy between Dante devices enrolled in secure Dante domains and Dante controllers on the network. But for those entry people who may not know what a proxy is, let me explain it real quick. A proxy server acts as a gateway between you and the internet. It's an intermediary server separating end users from websites they browse. In our case, Dante devices from Dante domains, or Dante controllers. Proxy servers provide varying levels of functionality, security, and privacy depending on your use case, needs, or company policy. This functionality extends to not just Dante controllers running on computers, but also embedded Dante controllers built into devices such as DSPs and mixing consoles. It's also very important to mention that if a standalone DDM server goes offline, the existing audio and clocking will continue to function, which means unlike a proxy server, data flow between devices are not affected by the DDM going offline. The control communication will be disrupted, which means no changes can be made to the Dante devices until the server is back up and running. A huge factor in determining your DDM server type will revolve around your particular use case. In fixed installs where Dante settings are not changed frequently or the set and forget type of installs, a standalone DDM server is perfectly fine to use. Examples of these are conference rooms, classrooms, training rooms, and background/foreground music systems. There are, however, other environments where changes are frequent, sometimes even on an hourly basis. These systems have little tolerance for downtime and hence will require a more resilient setup. This leads us to DDM's high availability feature. In the IT world, there are network servers that operate in something called high availability. This function means that an IT system, component, or application can operate at a high level continuously without intervention for a given period of time. High availability infrastructure is configured to deliver quality performance and handle different loads and failures with minimal downtime. In our case, the HA feature will allow DDM systems to continue normal operation in case of a server failure. Well, high availability is a redundancy feature that enables a backup server to take over if the main DDM server goes down or offline. If the auxiliary server detects that the active server is offline, it takes over as the active DDM server and all Dante clients will connect to it. So in other words, it allows a DDM system to continue normal operation in the event of a server failure. It should be noted that the existing audio will not be disrupted because, remember, audio doesn't pass through the DDM, and the control connections will resume as soon as the auxiliary server assumes the active role. Now, how do you set up the high availability mode of DDM? Well, you'll need 2 additional servers, assuming you have already set up the main server. They will need access to an NTP server, which the public internet is fine, and the DNS for the automatic device discovery in HA mode. From an implementations perspective, it's always easier to set up the HA mode from the onset of the project. Adding HA mode later once the DDM has been active, which is definitely possible, will require some configuration to ensure the Dante devices are discovered. We do have several resources and documentation that can aid you in the process. Okay, but now, what is the function of the third server? We have the active, the auxiliary, and then the arbiter. But what does the arbiter do? Okay, the arbiter serves as a tiebreaker in the event the network becomes partitioned, in which case the server is still in communication with the arbiter to take over as the active server. Note that if the main DDM goes offline and the auxiliary server becomes active, when the main DDM server comes back online, it does not automatically become the active server. This must be manually done in the DDM browser interface on the high availability cluster status page by using the Change Active button located near the top right of the page. This is by design to ensure that the main DDM that had failed has been revived. So this is an example of a high availability system. To set it up, First, you must set an IP address for each physical machine or virtual machine. As you can see right now, we have 192.168.1.4 for the active server, 5 for the auxiliary, and 6 for the arbiter. Then we set a fully qualified domain name for each one, and then the cluster gets a virtual IP address and a virtual domain name, which is what the devices are registering when they are enrolled into domains. So, they are not actually registering with the active or the auxiliary server. They are registering with this virtual IP address. Now, it's time to show you how to install the ESXi clusters. In order to enable high availability as we mentioned before, we will need a total of 3 DDM servers. Note that when we specify the number of CPUs, RAM, and storage for the high availability redundant node, this must match the settings used for the main DDM server. The high availability arbiter can use fewer resources. The installation process for the 3 servers are initially the same. The only difference is when we select the installation type. For example, you will choose the high availability redundant node for the auxiliary and HA arbiter for server intended to be the arbiter. Let me show you. Once you have already installed the 2 additional DDM servers, we just need to power them on to finalize the installation as we did with the first one. So, if we go to our initial DDM server that we previously installed, we're going to change the host name because it's the first server of the cluster. We also need to change its IP address since the DDM cluster is going to reuse the main server's IP address as the virtual IP address. We are going to name it DDM1 with the new IP address. This is a good process to follow when the upgrading from a standalone DDM to an HA cluster. So my first server is going to go to the 101 IP address, and remember that if we change these settings, we must reboot our server. While it's doing this, we can move to the second server, which is going to be the HA only node, and follow the same steps. We're going to change the host name of the server and its IP address. So let's call this new server DDM2, and let's assign a static IP address that is in the same subnet as the first server DDM1. Remember that all 3 DDM servers need to be on the same subnet. We will use the 10.101.1.102 IP address with the subnet mask at 24 bits, the DNS and gateway in the 10.101.1.1, and finally the search path at love.emea.dante.onl, which is the same as the first server. We reboot the auxiliary node, and now we move on to the DDM high availability arbiter, and we do the same thing. We are going to give it a host name, DDM-A, and configure its IP address to finally finish rebooting the server. Now, all of the servers have 3 different IP addresses with 3 different host names that have been recorded in our DNS. So the next step is finishing the installations through the web interface. Let's open a new window in our web browser and let's reach our first server. We log in using the same credentials and connect up. So let's open another web page with the server that is going to be the HA only node. And remember that this server is going to be able to take over the DDM application in case of failure of the initial main server. Once we accept the EULA, the next step is very important because it's the only time we get to pick the installation type. Because this second DDM installation is going to act as the high availability redundant node, we must select that option here. By doing so, we are not required to do all of the configuration that we did with the main DDM server. Okay, so if we go next, we're going to see that the high availability HA only node is licensed using the same key as the first one. As a reminder, your DDM license needs to be either a platinum license or has the add-on that allows you to run it as a cluster in HA mode. At this point, we will have our second server ready to become part of the DDM cluster, and also we will be ready to go to the next server, which is the arbiter. To move to the third server, we must open a new web browser window and access through its IP address or path name that was registered on the DNS. As you can see here, all of the 3 servers have different fully qualified domain names. In the third server, once again, we accept the EULA, and in this last installation, we must select the High Availability Arbiter option. The arbiter does not need to be licensed. After the installation, we must form the cluster, but how do we do that? Well, first we need to go to the DDM assigned as the main or active. Go to Settings and select the High Availability option. There, we will enable the cluster settings and type the IP address that is going to be used by the DDM application, which, if you remember, was the IP that was originally used by the standalone server. With what we've shown, it always makes sense to plan for high availability early on in the process, before you begin enrolling devices. That is really recommended best practice. You can use some of the examples we gave before to determine if your deployment needs or will need high availability. The virtual IP we're going to use is 10.101.1.100. An important step in the installation is that before saving the changes, we must copy this security key and import it to the other servers. Otherwise, the cluster is not going to form properly. So let's copy it from the main server and go to the HA only node. Select Edit in the security key and paste it. We do the same for the arbiter, and that's it. Now we can save the changes. We'll see that the main server is going to connect to the secondary server to build the cluster, and after a while, it's going to proceed with the arbiter. So if we speed this up, we'll see now that our cluster has been created, the virtual IP has been enabled, and the 3 servers are running healthy. Basically, the active or main server runs the application. In the event of a failure, the auxiliary, which is essentially a copy of the active server, assumes the DDM functionality. There is no breakage of continuity in terms of configurations, device allocations, and other settings. Since the Dante devices use the virtual IP to access the DDM cluster, nothing changes at the device level. Don't be alarmed if you get an error when trying to reload the auxiliary server and the arbiter. This is normal because we don't have access to them anymore. If we need to update the DDM or regain access to the separate servers, we'll need to disband the cluster. So if you go to the Settings section, High Availability option, you will see that the first server is running, but we can manually produce a failover if we press the Change Active button. During a failover, Dante controllers will disconnect and need to be reconnected to the DDM. The browser access will refresh automatically. This is brief and a part of a failover process. You can see this change reflected on the dashboard of the DDM web browser. In the event of a major issue requiring rebuilding a server, you can disband the cluster and convert the HA-only node into a standalone installation. You also have the ability to disband the cluster if you go to the appliance menu on the 3 servers, just in case you need to regain access to the individual servers again.